where they get up and go, okay, let's go make this happen. You know, nor is it the case that there's a couple termites who are the bosses going, okay, dude, you take this piece of grain and you climb way up there and put it to the left. No. What termites engage in is these very simple kinds of behaviors that through self-organizing kinds of processes leads to this incredibly emergent structure. The mistake we would not want to make is to take the structure, the thing that's done, and then stick it inside the heads of the termites. The analogy I want to suggest to you is a lot of complex behaviors that human beings engage in may be like these termite minds that we don't necessarily want to stick back into our heads. We're not termites, but we may be a lot closer to them than we think. And because of the fact that we, too, actually engage in principles and behave in principles of self-organization. Excuse me. Here are some, I don't know what these are, some kind of birds and stuff. You know, birds, they do all these flying, and they don't bump into each other, and they shape, and so it isn't like there's a guy over here, okay, Bill, you fly like 2 inches to the back here, and go half a mile, and I'll go over here. Or there's some head bird that goes, okay, guys, line up, and we'll do it this way. No, they self-organize by following simple kinds of principles from which complex behaviors emerge in context. And they're specific to the context at hand, namely wind conditions, the environment, time of day, their biology. That's all interacting to produce these complex kinds of behaviors. This is a picture from the Tour de France. This is a lovely regularity and experience. A lot of people are doing this similar kind of thing, but they're organized in this particular way. And although many of these guys perhaps know that this is a good way to do it, the argument is that this is something that naturally emerges. This is a regularity experience. But if you look at the Tour de France, there's all sorts of crazy variability. They're all stretched out, and they're clumped together, and then they stretch out again. And there's both the points of stability, and then there's points of variability. How do we account for that in the context of this dynamic human event of the people interacting with one another during the Tour de France? Excuse me. Here's another example of self-organizing principles that I think is interesting. This is simply a graph or a picture of a tank of water and oil where they've taken a series of bars and they've just pulled these series of bars through this solution once. And the top left is what the solution looks like after 1 second. The top right is after 10 seconds. And the bottom left is after 10 minutes. And the bottom right is after 1 hour. So notice here that there are these patterns that are emerging over time. And essentially, this is an example of how these things self-organize that unfold in time, given the particular sense of the local interactions of these molecules and the kind of structures that emerge. And the structures that emerge actually then have a top-down influence on the nature of the molecules. So there's this kind of reciprocal causality here that gives rise to these patterns that, again, are not given from outside, but are in fact actually reflections of self-organization. Other kinds of self-organizing systems that have been shown in natural life here is the foraging patterns of bees and ants, the dynamic shapes of flocks of birds, the symmetrical patterns of butterfly wings, the spots in a leopard's skin, things like the formation of different kinds of whirlpools and rivers, the formations of bacterial cultures, autocatalytic chemical reactions, dynamics of traffic jams and freeways, which I'm going to talk about in a second. The birth of galaxies are self-organized systems. And of course, the brain is really the ultimate self-organizing system. It isn't just sitting there waiting to do stuff. It self-organizes, and many very interesting properties to that gives rise to a lot of the kinds of behaviors we have. So some of the features of self-organization in general and abstractly here is that they tend to be systems that have absence of external controls, that is, they're autonomous. Quite importantly, people who are interested in studying self-organizational principles look at the dynamic of operations, the unfolding of behavior in time as a result of these self-organizing systems, looking at the temporal nature of these processes. They have multiple equilibria, so that there's many points of of stability or attractor systems, or attractor basins that shape behavior at any one time. And this will be seen as quite relevant. We can think about the constraints on self-organizing systems as existing in hierarchies, where these hierarchies have different time scales associated with them, which is something that's important. And again, we have this kind of circular causality, that is, we can get global order from the emergence of these local interactions, like these little termites doing these little things give rise to this global order. And at the same time, as this global order comes into being, it has a top-down influence in affecting the nature of the local interactions of these things, of whatever it is you're studying. Traffic patterns and freeways. So these patterns are not, for example, imposed by external force or some kind of external agent. Traffic patterns exhibit moments where the traffic flows easily, but then bottles up into different traffic jams, which exhibits what are thought of as these non-linear kinds of stabilities and instabilities over time. Sometimes things are stable, sometimes they're not, just like people in my experiments. They're influenced by various kinds of attractors or things from past experience or things in the world, such as roundabouts, traffic signs, and weather patterns. The traffic patterns arise both from these fast-acting local interactions among several cars doing their little thing, what's happening right now for just a couple cars. And then there's these slower developing patterns that arise from traffic flows, patterns across an entire city. So there's several kinds of levels we can think of what's of influences and constraints, traffic patterns, and these each have their own time scale. And again, that the large-scale freeway paralysis sometimes emerges from very smaller interactions among just a few individual cars. And at the same time, there's an emergent structure of a traffic jam that decides when individual cars must stop and go. So again, we have this circular causality here that I think is very important to thinking about a lot of aspects of human behavior. So let's consider, just very, very broadly, some of the kinds of what I think are the time scales that are constraining our experiences in the world at any one moment. And this includes